Good morning. I hope you guys are doing well today. Today we're going to be kicking off Unit 10 with our first lesson over slope-intercept form of a line. So one of our learning targets is I can graph an equation in slope-intercept form. So with this first part, screen is not moving. There we go. With this first part here, we're just going to talk about what slope-intercept form is, what it looks like, and what it's made of. So I've actually got right here it already written out for you. Slope-intercept form of a line is the equation y equals mx plus b. Y and x are just normal variables. You can plug in numbers for those. But m and b are two specific variables. If you guys remember from last unit, the m represents slope. We should be pretty familiar with slope. So the m is slope. You remember the rise over the run. B is new. B is what we call the y-intercept. The y-intercept is simply where our line crosses the y-axis. Our y-axis is the vertical one here. So for this problem, where our line crosses the y-axis is right here at 4. So it crosses at 4. Oops, so the y is 4 here. Just to fill this stuff in up here up top, we use letter B to represent y-intercept. The value of x when a point on the for a point on the y-axis, well, the y-axis, the point for x is always 0. So x is always 0 whenever on the y-axis. So for an ordered pair for this specific problem would be 0 and 4. So 0, 4. Again, the y-intercept, which is our b, is simply where our line crosses the y-axis, and it crosses at 4. So looking at this here, slope-intercept form is always y equals mx plus b. So just quickly identifying slope and y-intercept. For this first one, the slope, m, is just 3. It's the number being multiplied by x. The y-intercept is always whatever's being added or subtracted at the end. So in this case, we've got a plus 5, which means our y-intercept is 5. For the one below it, slope is the number 2/3, and the y-intercept is the number -8. Again, slope is the number being multiplied by x. Y-intercept is the number being added or subtracted at the end. For this next part, I know I'm skipping a couple of these, but you should be able to get the other ones on your own based on the problems I give you here. For this next one here, we are going to write the equation based on the information given. So again, it's always y equals mx plus b. So the equation is always y equals, and then mx plus b. So m is -3/7. So mx plus b, and the b is 2. So y equals -3/7x plus 2. And for the next one, again, y equals our m value, so 4x plus b. b is -5 though, so I'm actually going to write it as -5. Y equals 4x minus 5. And that is simply writing it as an equation. Now, on to the actual meat and potatoes of the lesson. We're going to be graphing lines, graphing lines with point and slope. Sorry, not with point and slope, sorry, with slope-intercept form. So for this problem here, y equals 1/2 x plus 5. The y-intercept is 5, which gives us the ordered pair 0, 5. So I'm going to go ahead and plot that point. And really, the plus 5 here, all it tells us is that we're going to go from the middle, and we're just going to go up 5. And that's going to be one of the points on our graph. So we know our line's going to cross the y-axis right there. The slope is the number with x, so the slope is 1/2, which means we rise 1 and run 2. So rise 1, run to the right 2, and there we have it. We just graphed slope-intercept form. So graph the plus or minus at the end first, then graph the slope. Moving on to the next one, y equals 2/3 x minus 4. Again, the y-intercept is minus 4. So I'm going to go ahead and graph that. You go down 4. 1, 2, 3, 4. And the slope is 2/3, which means we rise 2 and run 3. So up 2, 1, 2, over 3, 1, 2, 3. And there we have it again with my perfectly straight line. Go ahead and try, obviously not this one. Go ahead and try this one on your own. Pause the video, and then go ahead and play it and see if we get the same thing. Alrighty, you should have paused the video. Y-intercept we have is -1, and the slope is -2, which means we are going to rise -2 and run 1. So plot the y-intercept first. -1 means down 1. And the slope is -2/1, so up 2 and left 1, or down 2 and right 1. Either one of those would work. And that would give us this line here. Hopefully you guys had something similar. If not, go ahead and change it. We're not going to do this problem here. It's going to be pretty much the same thing. We're going to do this one here. So again, we're going to graph this equation here. But we need to rewrite it in slope-intercept form first. So if you guys remember slope-intercept form, it's y equals mx plus b. And if you see the y is all by itself, well, in this situation, the y is not by itself, and we need to get it to be by itself. So 2x is what we need to get rid of first. We can subtract the 2x on both sides. That way this 2x cancels out, and it leaves us just with 3y on the left. And on the right, we have -2x plus 3. And again, the y is still not by itself, so we must divide by 3 on both sides. And make sure you divide everything by 3, not just the -2, or not just the 3, but both the -2 and the 3. Those cross out, we get 1. So we have y equals -2/3 x plus 1. In this we can graph. The plus 1 tells us up 1, and a -2/3 slope means we go up 2 and left 3, or down 2 and right 3. And there we go. So these are graphing with slope-intercept form. Now we're going to get a little look at just looking at the equations themselves. Find the slope of a line parallel to the graph of each equation. So if you guys remember, parallel slopes are equal. So if I wanted to write a new equation, y equals, actually, we're not even going to go that far. Parallel slope for this problem, well, the slope is 1/2, so the parallel slope would still be 1/2. For number 2, parallel slope again is the same, so it's still going to be -2/3. And this last one is the tricky one, y equals 7. We're missing the mx part. So if you think about it, we have y equals, this is a +7, so I'm going to put a +7 over here. But since the x is gone, that means we have 0 times x. Because if we were to simplify y equals 0x plus 7, the 0x would just be 0. And 0 plus 7, 7, which would give us y equals 7. So we don't need to write all of this out. We can just write y equals 7 because it means the same thing. But for the slope part of it, the slope is parallel, so that means the slope is still 0. Perpendicular is a little more tricky. If you guys remember the rules for perpendicular, it is the opposite reciprocal, which means we're going to take our fraction, flip the sign, and flip the numbers. So if we look at the slope for number 4, it's -7/5. Well, for it to be perpendicular, it would need to be 5/7. It was negative, now it's positive, and we flip the 7 and the 5. Same thing for this next one, y equals 4x plus 8. Well, we want the opposite reciprocal. It was positive, now it's negative. And we have to flip it from 4 to 1/4. And one last problem, this one's the trickiest here. We have y equals -2. Now, earlier we were talking about y equals 0x plus 7, so that would remain the same here, y equals 0x minus 2. But that doesn't really help us in this situation because the opposite reciprocal for 0 is still 0. So let's think about the graph instead, what it would look like. If we graphed y equals -2, it would give us a straight line going horizontal like this. We want something perpendicular. So if it is going straight side to side, that means we need a line going straight up and down. Take a second and think, what does the equation of a line look like that goes vertical like this? Pause the video, take a second, think about it, and then play it if you have an answer. If you said x equals, that would be correct. So a perpendicular equation would be x equals, let's say, -2. You could pick any number here for x, it does not matter. You could have picked x equals 17. It would be perpendicular. Because x equations make a straight vertical lines, while y ones will make a horizontal, which means they're going to make that T shape, that little intersection like this. One last problem. Two last problems. We're going to look at 7 and 8. Rewrite the equations in slope-intercept form if necessary, then tell whether the graphs of the lines are parallel, perpendicular, or neither. So if we look at number 7, y equals 2/3 x plus 6 and y equals 2/3 x minus 6. Well, to tell if they're parallel or perpendicular, we have to look at the slopes. The slope here is 2/3. The slope here is 2/3. That means these will be parallel. That's an R. That's a P. Parallel. Same slopes are going to equate to parallel equations. And number 8, we have two equations again. However, the one on the right here is not in slope-intercept form, so we have to make it slope-intercept form. So, got to get rid of the 2x first. So subtract 2x on both sides, leaving us just with -5y on the left. And on the right, we have -2x plus 20. And then divide by -5 on both sides to get y completely alone. So y equals -2/5 divided by -2/5 is going to be a +2/5. X positive 20 divided by -5 is -4. And so now comparing these two equations, y equals -5/2 x minus 2 and y equals 2/5 x minus 4, the two slopes here are the opposite reciprocals of one another, so this is going to be perpendicular. And there we have it. I hope this made sense. If you guys have any questions, please feel free to reach out to me and definitely ask questions in class. Hope you guys have a great rest of your day.